We are Paul and Dave. Paul really needs no introduction in this room, I think, but I will introduce you anyone. Ladies and gentlemen, Paul Everitt. Paul is the head of developer advocacy at JetBrains, and you can find him in the PyCharm booth downstairs. And I am an indie developer based in sunny Seattle, Washington, which means that I'm a computer weirdo, basically, and I get into all sorts of computer mischief, hopefully of the good kind. And one of the bits of computer mischief we got up to recently is Paul and I, along with Kudai, who's sitting back there, and a few other people, co-authored PEP 750, better known as template strings, better known as T-strings. So we're gonna use all these terms. They're all interchangeable. And I just want to say before we go forward, it takes a village to put a PEP like this together. We co-authored it. There's 7 authors on the PEP itself. If you go to discuss.python.org and take a look at the discussions there, they are legend. And actually, Michael Kennedy, when we was on his podcast, said he printed them out, just one discussion thread, and it was like 216 pages. So like we literally wrote a novel talking about whether T-strings and how T-strings should work.
Python people have opinions. Who knew?
Yeah. So T-strings, they are a feature that is coming soon. They're going to ship in Python 3.14, which goes out later this year. And if you've got the 3.14 beta, you've got T-strings. They made it into the beta, which is exciting. So today, Paul and I are going to tell you a little bit about what T-strings are and what they aren't. So try and make sure we kind of clear up some common confusions that came up during those discussions. We're going to talk about why T-strings are, like why did we want to do this at all? And then we're going to look at how T-strings, HTML, and Flask might play together in a fun and hopefully chill way. And then we're going to do tooling for T-strings and some extra sizzle at the end. All right, so what are T-strings? Well, like we said, it's a new feature shipping in Python 3.14. And the way I think of them is that they generalize F-strings. And what I mean by that is they help make F-strings safer, and they also help make F-strings more flexible. And we're going to spend the next 30 minutes talking about what we mean by those two things. So generalizing F-strings. Well, first and foremost, T-strings and F-strings have the same syntax. So if you see the F right there, just keep your eye on that. This is, of course, valid Python. And this in Python 3.14 is valid Python. I just put a T there where the F was. I really want to drive it home. Here's a little fancier F string with a format at the end. And we can just put a T there, and it's the same syntax. So T-strings and F-strings look a lot alike. And T-strings and F-strings are both eagerly evaluated. So if you hear the word template, you might think, oh, this is something I'm going to substitute values into repeatedly when I call my render template function. But no, template strings actually work more like F-strings in the sense that the expression friend in those curly braces is eagerly evaluated. And what I mean by that is if I comment out that first line, then the second line with the F-string is going to result in a name error because friend is not defined. And same thing with template strings. Friend isn't defined here, so we're going to get a name error. And of course, if I comment back in friend equals world, it's all going to work out just fine. But there is an important way that T-strings are not like F-strings. So here we have an example. We have name equals world, and we're going to print out the type of the F-string. And as you know, F-strings are just plain strings. So by the time an F-string finds its way to your actual running code, all you know is that you have a string. And this is where template and T-strings really differ. Here, the type of a T-string is this new thing that's shipping in Python 3.14, string.templatelib.template. It's a bit of a mouthful, so I'll just say template from now on. All right, so why do we want this and what is it? Well, in an important way, T-strings are not strings. So as we saw, you write them like they are. I guess this is not a pipe for T-strings. But they evaluate to a new type template. And actually, this new type template doesn't have an easy path to getting a string. So if you just wrap stir around it, what you're going to get is the repr. The template type does not have a default implementation of stir. So this is probably not a string you want to send to your users or to a web browser. And this is sort of our first hint of what's inside the template type. We're going to look in more detail at that later.
Real quick, this was not an accident. Going back into all this discussion, again, people have opinions. There was a lot of opinions on whether it should be stringable out of the box. There was a lot of discussion. It was originally lazily evaluated instead of eagerly evaluated. The whole PEP process was really interesting, finding out what the community wanted. And thank you very much for being willing to answer all the damn questions. That was out of control.
So the thing that you have to do with templates, once you have a template instance, you have to process it to use it. And so let's talk a little bit about processing templates. Well, templates are just normal Python objects. And so you can write or call any code you like to turn them into a string by looking at the bits inside the template, or to turn them into any other type. And we're going to show examples of both of these in a second. So, but before we get there, I definitely want to ask the question, but why? So let's talk about f-strings for a second. So f-strings, when they shipped in Python 3.6, took the Python world by storm. They get used a lot. I think they get used more than basically any other string formatting approach that I'm aware of these days. And that's because f-strings rock. They are powerful, they are readable, and they have a really, really nice syntax that's easy to grok. And by the way, I used AI to generate this, and I asked it to give me an image of a rock band that's awesome and rocks. No comment on this.
Count the number of the strings on the bass.
Yeah, it's seriously, that is a crazy looking bass. So f-strings have been adopted by developers far and wide in the Python ecosystem. But the catch is they're also misused a lot as a result of being used a lot. And so here, and by the way, I asked the AI to pretend that that same rock band were my code base, and my code base had security vulnerabilities. And this is what it gave to me, which I think is just ridiculous. There was GPT-4.0. So f-strings get misused, which results in SQL injection and cross-site scripting vulnerabilities in HTML. And so this is the primary concern that started us thinking about PEP 750. This is little Bobby tables. How many of you have seen this XKCD before? I figured pretty much everybody. So mom gets a call, and it turns out she chose a funny name for her son. So little Bobby tables, let's actually implement a injection vulnerability for a second. So I have a method called getQuery, and it's just going to return a student whose name is a given name. And of course, I'm going to call it with little Bobby tables here. And that's it. That's all it takes for me to be sunk. When I execute and send the resulting string to my database, I'm going to drop the students table. And it's worth thinking of for a second from the perspective of the author of the SQL library itself. They have to write this execute method. Now, real SQL libraries have all sorts of fancy types for the types they accept within their execute methods. But if you were just writing query stir, you're already sunk, because you don't know whether the bit of the string that's Robert apostrophe parentheses semicolon is something that you should trust or not. And so you just have to blindly send it on to the database. So of course, you can imagine a future version of execute will take a template rather than a string. And of course, the thing about SQL injection vulnerabilities is they're hard to see. So here's a Flask route. And we're sending a name from the outside world, which is very dark and scary, into user data. And we have a SQL injection vulnerability without obviously seeing it up front. The same thing applies to HTML. I don't know what Bobby's brother's name is, but it definitely applies to HTML as well. And so here we have render user. And if we call render user with a bit of script, we're going to get owned. Same kind of problem if I have a Flask route that looks like this and the name is coming from the outside, or even if the name is coming from my database, but the user originally supplied it, I've got an injection vulnerability here too. So we don't want that, and T-strings are here to make that safer. So with the template type, you can know which parts of the string are static and which parts of the string are dynamic. And you can't do this with f-strings because, again, f-strings are just strings. All right, so let's take a look at an example. Here I have an example bit of HTML, and I'm using template strings for it, so that's the T prefix there. And first, let's just take a look at what's inside a template instance. So here you can see, basically, it's just a sequence of the parts of the string. So the static bit, we've got div. And then we've got this funny new type, which also ships in Python 3.14, interpolation. And that's the thing that holds the value. By the way, naming things is really hard. I apologize for the very long name there. But it's a word that shows up in the Python docs and has since the very beginning. So it's one that we kept in this PEP. And you can see that the interpolation has a value, which is the substituted value for name, and then we've got the closing div tag there. You can also access just the static string parts with template.strings. So this is a tuple that contains div and /div. And you can access just the dynamic parts with template.interpolations. And I won't say too much about interpolation. We'll look at that a little bit later in more detail. But there are 4 fields on it. So the value is world. That's the substituted value. Expression here is the actual text of the Python source code in this case, so name. And then for those of you who are real f-string nerds, that syntax up there, the bang, exclamation point s colon right 10, that is valid f-string syntax. It's valid t-string syntax. And that becomes the conversion in the format spec inside the interpolation. So you really do get to see these templates as a programmer like an f-string after the parser has parsed it. So back to this kind of like just looking at the simple iterative view of template. And let's actually walk over the template. And if the item in the template is a static string, we'll print out static. And if it's a dynamic one, we'll print out the interpolation.value. And so that's obviously going to print out div, world, and /div. So now what I'm going to do is I'm going to add an array up here. And I'm going to replace my stir case with I'm going to append it right into the array. And in the dynamic case, I'm going to call an HTML escaping function first, and then append the result of that to my array. And then I'm going to grab and join all the parts together. Now, in this case, because name is safe, I just get div world out the other side. But if I change name to that scary script string that we saw earlier, this time the result is actually a safe string, so no injection vulnerabilities. Now, realistically, those lines of code that we just wrote to process the template are going to be from some library in the case of HTML. So some library that I hope somebody maybe in this room writes sometime soon. I'm going to import an HTML method and get a string out the other side. But once I'm building a library like this to process template strings, of course, maybe I don't actually return a string directly. Maybe for HTML, I return an HTML element. There's no reason, because this is arbitrary code, I can return a type that's more appropriate. And so now I, as the user of this HTML library, can go and tie HTML elements together, call methods on them. And of course, I can probably also get a string out the other side so I can send it back to the browser. So T-strings make F-strings flexible. You can imagine that this theoretical HTML example that we have here does a lot more. So for example, let's say I have a user ID and I want to include it in my div. Now, this is a little subtle, but you notice here I'm interpolating the user ID, but I didn't put an apostrophe or a quote before or after this interpolation. But the HTML function is smart enough to see that it ought to do that on my behalf. And maybe if I have a bunch of classes, I can treat them as a list, and the HTML function says, oh, I see this interpolation, it's of type list, and it's associated with a class attribute, so I'm going to join those strings together and put a space between them, because that's the syntax that I know that the user probably expects. And going even further, you can imagine having a dictionary of attributes and just dumping them directly on the div tag. So there's a lot of potential power for what you can do when you're writing code that processes T-strings. Taking a look a little bit further at this, you can also, of course, build huge pages this way. And so you can kind of start to compose these features, these syntax features that your HTML function gives you. And here's an example of a Flask route that returns a user page that's rendered by T-strings and this HTML method. And really all the magic is there at the bottom when you call HTML to take that template and turn it into a final HTML string. So naming things is hard. As I mentioned before, T-strings are eagerly evaluated. You don't keep calling render template on them. So I guess you could ask, are templates templates? And that depends a little bit on what we mean by template. If you're thinking in terms of Jinja or Django templates, no, they're a little different, although you can substitute them, their uses. If you come from the JavaScript world, you may have encountered JavaScript's tag template strings, and these are a lot closer in sort of vibe to those. So how do I keep calling or reusing the same template string? Well, you just use Python. So here we have two different greetings, and we're going to call and get two different template instances out the other side. So just a quick down the rabbit hole, we saw a really simple implementation of HTML that we wrote with a simple for loop. And we saw kind of some hints of something fancier. So what does that HTML method actually have to do? Well, the answer is it's got to do a lot. It's got to parse the template. HTML has a grammar, a formal grammar, that it needs to be parsed. And it's got to examine each substitution's type and position in the underlying grammar, and then decide, based on those two things, how to actually render each value. So building code to process t-strings can be fairly deep in practice. And so with that, I think I'm going to turn it over to Paul.
All right. Tell some jokes while we're doing
while we're doing the handoff.
And this Has anybody ever written a PEP? Raise your hand if you've ever been a part of a PEP. All right.
New experience, man.
Me too. When Jim and Gui, you want me to take the?
I put it right. I put it right there.
When Jim and Guido started implementing this a few years ago, I kept thinking, oh my God, it'll make it into 312. Past me was so naive. Yeah.
Developer did a heroic job to actually do a bunch of the implementation and get it into the first beta. We almost didn't make it.
Yep. All right, we good? I was supposed to tell you that we're about to do the swapping.
Yeah.
Apologies. Okay, let's have a little bit of fun. Let's start with the obvious question. Who wants a new templating language, right? Anyone? Anyone? Who wants to not write a compiler for an old template language? Yeah, there we go. We're going to talk about this a little bit today and try and get you framed and then finish a little bit with really let's have a much bigger story where we're all working together and all having fun on things. And as Jim mentioned, I'm developer advocacy, but I'm also like big time. Raise your hand if you love the web. Ooh, please raise your hand, yeah. Raise your hand if you have done React front ends. Raise your hand if you would like to come back. No, come back to Python. All right, good. For the record, 100%. Everybody. When you go over to the world of React, particularly when you go over to the world of TSX, not just JSX, TSX, you cry a little, you die inside, but you get this really great developer experience. Can I give you a plug at the end? Okay, all right. You get this really great developer experience because people have agreed on some standards, there's some tooling and things, linting, formatting, type checking, refactoring, all of these great things that IDEs can help you on, and Prettier, and the TypeScript compiler. One of the reasons is JSX is close to the language. They didn't invent their own for loop, they just used map. And you see it here. I'm in the middle of some complicated code. This isn't even React, this is 11D, and I'm using an alternate JSX implementation because, duh, standards. And they're just using the thing in JavaScript you would have had to use. So if you've got a tool like TypeScript that can look at code in JavaScript, it can look inside here and squiggle you. Down here at the bottom, you see a component. Inside something that looks like markup, and the attributes in HTML are props that get passed to the component. And I got squiggled because the contract said you were supposed to send me something, not a number. You were supposed to send me this type of thing. So you get coding assistance, you get quality assurance, and a blend between where's the language and where's the template. What if, in a magical world, we had something that was a little bit more of a modern developer experience for templating? Word modern, it's doing a lot of lifting there. What do I mean by modern? Something that understands static analysis and type checking. And so all the power of those things can come in to speed you up and let you know when you're wrong. And what if we did this around some community standards? What if we got a group of people who are passionate about this and defined the rules so people could go out and make a bunch of stuff that interoperated, that was high quality? We don't have enough talented web designers in the world of Python to split them across 47 different frameworks. It would be so awesome if I could just get a theme and use it in Sphinx, or use it in Flask and Quart, or use it in Django. Same thing for components and tooling. So with the arrival of T-strings in this package we're working on with the fine folks at Anaconda, Andrea's working on it, called TDOM, we hope to bring these ideas forward with anyone that wants to participate with us on it. It is an easy step. Dave just showed you F goes to T, and everything else feels the same. Ask Ned about this, like coverage.py. He had sys monitoring in 3.12, but it didn't have branch coverage. It just landed in 3.14. I was talking to him last night, and he said, if it's close to F strings, I can look at it. I don't have to go teach coverage how to look at Jinja. And then there's this longer range question. If we had a templating language that was closer to the Python language and closer to type hinting and all of this stuff, could LLMs generate more reliable code? Open question. All right, let's go for a demo. Fun fact, I'm an idiot. This is, in my long, dishonorable history of ambitious demos, this is the most ambitious. I'm using a PyCharm nightly build for the next release, combined with CPython 3.14 beta 1, combined with 2 plugins written by Kodai about 7 seconds ago, and as you'll see in a bit, a branch of Rough that he also wrote a plugin for me. Here we go. T-strings are now supported in PyCharm. It wasn't that hard. They just had to make an F look like a T. But if you have an F, you get a string. But if you have a T, you get a template. Just like in F strings, I can get fun little things like autocomplete. And then navigation to that symbol. Walk up to it, go to the name. Hey, that's not good. I want first name. I want refactorings. It's just like an F string, and the IDE, lots of the smart editors and IDEs from all of our friends in Python can do this stuff. Just teach it F is a T is an F. Hey, is an F a T and an F? I want to convert that to an F string. No, I want to convert that back to a T string. These things become pretty easy because we've lowered the bar, lowered the distance between the language and between the template and the language. All right, so we can also auto-import functions and things like that and use standard tools like debugging. Raise your hand if you loved Pamela's talk on testing. All right, cool. We should always be testing. Raise your hand if you should always be debugging. Hell yeah, 100%. Always be debugging. So with this, I could, for example, import that function. And then I put that back to first name, so let me fix that. I got squiggled. That's a good thing, not a bad thing. I can walk up to this thing and run it under the debugger, and because my tool knows how to step into F strings, it knows how to step into T strings. Let me step into it. Oh, there's my function. Cool. As I step in, it takes a template, Paul likes type hints, and returns a string-like thing. And so I'm going to step through this, and the first item through is a static string. It's a string. No problem. So it's going to be the str case. And I'm just going to append a lowercase because I'm writing business rules. I'm writing a DSL called lower upper because my company wants lowercase static strings, uppercase dynamic strings. So then I go to the next case. Next case, ooh, it's an interpolation. That's what Dave was talking about. Let's take a look at that interpolation. It has a value of world, but if I wanted to go get back to the thing in the curly braces, I have access to it. And I could analyze it and do something interesting with it. I'll keep going, and on the way out the door, we will join the parts and send them back. back to the demo for the please God let it work part. So this library that the PyScript folks are working on, called TDOM, I've imported it. Yeah, I know it's not at the top. Oh, and I also get rough formatting. So let me do the rough formatting part first. I will put a space in here, and I'll put some space in there, and some space in there, and I will run rough, or even better, I've got it set up to run on save, and it reformatted it for me. What if I was, again, an idiot, and I use single quote strings, and everyone in the world of Python hates me? I don't want to be hated. Thank you, Rough, for putting it back as God intended, double quoted strings. Now, if I were to type all this, hold on to your butts, this is going to be fun. PyCharm knows that that looks like HTML and injected the HTML language into it with F strings. So it's a mixture of the two. So I can go into the middle of this and say, hello, first name, and have my F string in HTML with rough formatting on the Python parts. That's not so bad. Let me wrap up with the part that I've gotten irrationally excited about, which is component-driven development like you get in React. Let me import that. Okay, you're okay. With this, I can, for example, get autocomplete here. But also, Kodai did this for me. This is my component. It requires a parameter called name, and that has to be a string. What? IDE autocomplete. And now my component renders. What if I did this? If I change that to an int, what do you think will happen? Squiggles? Squiggles it is! You sent me a string, dummy. I wanted an int, and in fact, you're so dumb, you forgot to send me anything at all. A name. This is the kind of IDE assistance, type checking, tooling that you get from TSX. This can be our world too. If we come together on some of these things, agree on some standards, and then find ways to get interop with the existing world. So for example, a few years ago, I wrote something called Jinja 2 components on a predecessor of this. And the idea with that was you write these little simple components. Back then, it used a Jinja string. But you write these simple little components. And in the middle of Jinja, you do that. You do that. And so you've got something that looks like a component, and then arguments you pass to it, and you do an inspection of the signature and squiggle if you need to. And with this, I was putting it in the AST, so it felt completely normal to a consumer of a component. We can write components. We can write components that work in Django, that work in Flask and Quart, that work in Sphinx. I used this to write a theme for Sphinx that didn't know it was running in Sphinx. It could have run in anything. These are things that we can do. We'll go ahead and switch over to closing remarks, but you and I will have to share this.
All right, so in closing, Paul and I are very excited about T-strings, and we're really excited about the broader ecosystem of tools that we can bring to bear now that T-strings are shipping in 3.14. So I'm looking forward to seeing what libraries and tools you all build and exactly how you build on top of T-strings. So call to action, say hello if you're interested in talking more about this. We're holding an open space tomorrow at room 320 at 11 in the morning. There's a sprint day on Monday. I have no idea what we're going to be doing, but I think Lysandra's going to make me write documentation. Yeah. And Paul is easily found in the PyCharm booth, and I'll be around too. And so will Kodai.
All right, thank you.
Yeah.